All right. Before we start this problem, I just wanted to point out that phosgene, which is the reactant in this problem, was actually used as a chemical weapon in World War I and was one of the really nasty chemicals used in trench warfare. It's incredible that it's still used in manufacturing today. You really, really hope that that manufacturing plant doesn't have a leak. Anyway, I already set up our rice table. We are going to need it in this case. Um, I want to point out that phosgene has the initial pressure of 1.0 atmosphere. So we're going to plug that in. All right. We also don't have any CO or Cl2 at the beginning because this is a decomposition. You can assume that both of the amounts of those are zero. So we're going to have minus x and then plus x for both of these. The coefficients of everything is 1. So it's just going to be minus x and plus x. So it's going to be 1 minus x and then positive x and positive x. I'll put a point O just to keep in mind sig figs. I'm going to point out that the Kp value here is extremely, extremely small. All right, if you really wanted to, you could just assume that 1 minus x is just the same thing as 1. The reason is, whatever amount x is going to be so incredibly small that it's going to fall out with sig figs, such that you don't even really need to do a subtraction there. The final answer is going to be 1.0 minus 0, or almost 0, and it's going to give you 1.0. But we're going to do this the legitimate way. I'm just going to point out that you can save yourself a lot of stress and anxiety with the math if you just say, oh, Kp is so small, x is going to be so small that it's going to have almost no effect on 1. So therefore, the answer there is really just going to be 1 because of sig figs. Anyway, let's set up the equilibrium expression. Kp is going to equal CO times Cl2. I'm using parentheses here instead of brackets because we're dealing with partial pressures instead of polarities. Notice it's products over reactants, just as always, that there's no exponents because there's no coefficients in the equation. And now we're just going to plug everything into there. So I know that Kp is going to equal 7.2 times 10 to the negative 11. I also know that the CO is going to equal x, and the Cl2 is going to equal x. So x times x will be x squared in just a moment. And that the denominator is going to be 1.0 minus x. All right. When I go and I simplify out that expression to put it into standard form, I'm going to get that 0 is equal to x squared plus 7.2 times 10 to the negative 11 minus 7.2 times 10 to the negative 11. Got an x in there. That's going to be x. When you plug that into the quadratic formula calculator on your calculator, the quadratic formula equation, you're going to get that x is equal to, I'm going to write it up here because I don't have any space left, 8.5 times 10 to the negative 6 atmospheres. All right, so we're going to plug that in. We know that that's going to be minus Cl. We know that that's going to be minus Co. And we know that 1 minus that incredibly small number is just going to be 1. So CO Cl2 is going to equal 1.0 atmospheres. That CO is going to equal 8.5 times 10 to the negative 6 atmospheres. And that Cl2 is going to equal the same number. All right. At the bottom, it asks for Kc. We've done a lot of that stuff before. I'm not going to actually do the math out, but I'm just going to tell you that the answer Kc is equal to 2.5